Hello and welcome to this very special interview on Digital Foundry concerning AMD's FSR 2.0. Today I'm going to sit down and interview Nick Thibieroz, the Senior Director of Game Engineering at AMD, who is integral to the FSR 2.0 project, to talk about how it is today on console and PC and where it might be in the future. So, welcome to the channel here, Nick. How you doing?
Hi, great to see you, Alex. Thank you for inviting me. It's great to be here.
Yes, thank you for joining me and taking your time out of your presumably very, very busy schedule. So let's start immediately just kind of getting into the motivations behind AMD's FSR 2.0. AMD, essentially 1 year ago now, almost, released FSR 1.0, an image space scaling solution. Building upon that, what did the team want to achieve with FSR 2.0 and why did they want FSR 2.0?
Yeah, no, that's a great question. So let's maybe spend a bit of time talking about FSR 1 first, right? So as you said, the tech was released more than a year ago, and we've seen really good adoption by game developers. And clearly we've been super happy with its success and got a lot of praise about many aspects of the technology, such as the quality performance trade-offs, the ease of integration, cross-platform support, and of course its open nature. So it's interesting because we could have chosen to build a super resolution tech for higher-end GPUs only. And in a way, it would have been easier, right? But it did not quite fit with what our developer partners and our customers wanted, right? So at AMD, we believe that super resolution is a tech that should be accessible to everyone, regardless of GPU vendor, performance, or accessibility. And looking back, I think we make the right decision, right? There's more than 80 games enabled with FSR 1 in the first year alone. And that means players can enjoy higher performance on whatever device they game on, right? So essentially, that means FSR 1 was our first solution to democratize access to upscaling technology. But we knew we were not going to stop there, right? So in terms of motivation, right, I would say that improving quality relative to source resolution was the main aspect that we wanted to go after, right? So FSR 1 looks great in higher quality modes, but clearly it starts losing some steam at higher scale ratios. And yeah, we wanted to improve on this, right? So real-time upscaling is an active area of research for AMD, and temporal upscaling across frames was the next natural step for us to look into, really. So that solution, right, that would allow us to use samples from previous frames to reconstruct the current frame was the logical way to go about solving and improving the quality. At the same time, we did not want to lose any of the values that made FSR 1 successful. Again, cross-platform, ease of integration, and open source. So providing a high-quality upscaling solution while retaining the pillars that game developers have come to expect from us was the main motivation behind the development of FSR 2.0.
Okay, awesome. And yeah, I mean, it's already seen such an incredible uptick already, I would say, FSR 2.0 in terms of announced titles. And FSR 1.0, beyond the official stuff that has been released on PC, it's also been added into Switch titles of other things. It's seen its way onto console titles. It's been added into things like RPCS 3 just as a default toggle. It's all out there. You can find it. And I mean, if you really want it, you can inject it from the desktop too. You know, there's a lot of ways to put it into a lot of titles. Okay, so you chose to use temporal super sampling essentially to get there. Temporal reconstruction.
That's right.
Now, we've seen temporal techniques for a long time, all the way back in Halo Reach on Xbox 360. I remember looking at it and being like, what is this ghosting? What is this? Why is this happening? It was one of the first times we saw TAA. Obviously, it's improved and changed dramatically since then in terms of how many frames it's using and the quality of just a static image. But, you know, that ghosting problem has always been kind of endemic to it. So how does FSR 2.0 actually approach that to try and eliminate it as much as possible?
Yeah, good question as well, right? And let me spend a bit of time on TAA, because I think TAA, temporal anti-aliasing, is actually a great example of how the game development industry shares and collaborates, right? Because we've seen, as you pointed out, that TAA is now pretty ubiquitous among games today, right? So with TAA being a building block for temporal upscaling, I think it was important for AMD to give back to the community by releasing and documenting our own efforts in this area, which is obviously what we've done with, by releasing FSR 2 under the GPU Open banner of openness, if you want. But regarding ghosting, right? So by definition, I would say that any temporal upscaling technique is going to rely on pixel information from previous frames, leveraging what we call motion vectors, right, to determine where current pixels used to be in the previous frame. Unfortunately, in games, pixels tend to move a lot, right? So you can't just rely on motion vectors alone, right? It may not be enough. If you're playing a game, like a first-person game, and say you open a new door, and there's obviously some new stuff behind that door, well, those pixels behind the door, don't have any history in previous frames, right? And that's what we call disocclusion. So in those cases, the temporal algorithm needs to find some other ways to infer detail on how to upscale those particular pixels, right? So there are some documented techniques on how to deal with those limitations, including looking at neighborhood pixels and clamping them to prevent reprojecting incorrect colors and therefore avoiding ghosting. And in fact, I would say, how history and current pixels are combined together is actually a major part of how well temporal algorithms work, right? Temporal upscaling algorithms work. And here, like the secret sauce, if you want. And here I would say FSR 2 uses variations between existing and new methods to limit the visual impact of ghosting artifacts. So we've got a bunch of technical details on this that I would recommend anyone to read, right? Like the FSR 2 documentation, I think is very good in that respect, or even our GDC 2022 presentation for the full spiel, right? But in any case, I think it's fair to say we expect to improve ghosting artifacts in the future, and FSR 2 will get better and better.
Continuing on, the already published work that you talked about, the GDC presentation, which was really awesome, as well as everything you can find on the GPU Open website. We know that games are made up of many passes, and temporal anti-aliasing in the past has done really, really well with like opaque stuff, but things that are transparent or, like animated textures and things like that, like surfaces that change in a way that is not really expected. That stuff has always caused problems in the past. So what was AMD's approach here to try and make sure that the upscaling stayed high quality, even for these screen elements?
Yeah. So I think your question hits the nail on the head, right? Games are very complicated beasts, right? They're made up of lots of different types of rendering. And that means, for high quality upscaling, FSR 2 has to be great at everything, right? But I think it's fair to say that transparency in particular can be challenging with temporal upscalers, right? And that's because those translucent pixels typically don't have motion vectors or even depth information. So you have to rely purely on color information to decide how to upscale those. Now, FSR 2 is equipped to handle a large variety of the more difficult cases out of the box. We've got something called like a detection mechanism for shading changes. And what it does is it looks for variations in the image that don't have a corresponding change in geometry, right? So we do have that to take care of these situations. However, we are all about giving developers maximum control. And to that end, we expose a mask, right? This mask that we call the reactive mask allows developers to essentially optimize the quality of their FSR 2 integration by tagging transparent pixels on the screen, right? And with that information, FSR 2 is able to produce a better upscale image by, if you want, balancing the historical data with the transparent colors in the current frame.
All right. That's. I mean, I have to say, in Deathloop, it worked out extremely well there, particularly because I haven't actually had. There hasn't been so many release titles as of yet, but in Deathloop, I found that the transparency issues that we usually find in so many other games with TAA were just basically not at all there with FSR 2.0, and it was really fantastic looking there. Just talking about FSR 2.0 quality, one thing that we have noticed, we've only looked at 2 titles so far, and these things can obviously change on a per title basis. So that's one thing. It depends on how deep the integration was, how much time they had, all these other things. We looked at technically what is considered a non-standard title, because I know officially FSR 2.0 through GPU Open supports Vulkan and DX12. Legacy API support really not there unless you work with you guys, apparently, and that's what happened with God of War, which is the DX11 title. And in there, we particularly noticed, and I don't know if it's just the way the game was, but when pixels were disoccluded, the things in the background that weren't there before are now visible in one frame. We noticed that a couple frames afterwards, in that area, there would be like the equivalent of like the resolution kind of jittering, or I called it fizzle in the video I made on it. one, is this like expected behavior based upon FSR 2.0's like working principles? And yes or no there, I guess, and a bit about background information. And if yes or no, is it like by design? Is it stylistic? And was this something that is going to be maybe changeable in future iterations of FSR 2.x, 2.01, 2.12, whatever?
Right. I don't think I've got a yes or no answer for you, unfortunately. What I would say, though, is upscaling is fundamentally a complex problem, right? You're trying to reconstruct a high quality signal from essentially a very limited set of inputs, right? So realistically, this process means that any temporal upscaling technology will be subject to minor image quality issues. And those will be typically more visible at higher scale factors or, of course, when the game is in motion, right? And they will also change, as you pointed out, on a per game basis, but often they will not be visible, or at least they'll be less visible at normal viewing distances and high frame rates, especially if you're targeting 4K resolution. So having said that, AMD is definitely invested in continuing to improve FSR 2 in many of its aspects, with image quality leading the charge. Our number one priority here is the player experience with FSR 2, right? And that means we optimize the algorithm based on typical playing conditions. But again, I expect FSR 2 to get better and better.
Oh, okay. Well, I can't wait to see whatever. I mean, I don't know how long the iteration times are, obviously, between your releases on AMD's, like GPU open stuff. You've obviously updated stuff in the past before multiple times. So I cannot wait to see whenever that may be. But even in the meantime, it feels like it's barely been a month. Maybe a little bit longer now. It's about like 1.5, 2 months now since it kind of came out. People are already doing really incredible things with FSR 2.0. I already know, for example, Dario Samo, whose content we've covered on the channel before, worked on the SM64, Super Mario 64 PC port, and added DLSS there, and he immediately picked up and added FSR 2.0. And another thing that we've seen too, which was kind of beyond the realm of imagination, was that people have been taking titles which have been released over the last 2.3 years, whatever, how long it's been since DLSS 2 came out. And people have been putting AMD's FSR 2.0 into it, kind of hijacking the .dll framework. One, was this by design? Did you expect this? And like, what is your reaction and what comment do you have about this phenomenon at all? People putting FSR 2.0 into retail games that did not have it before. Yeah,
I think what we are seeing here is honestly the power of open source, right? I mean, as far as AMD is concerned, open source is an invitation for developers to join us in innovating, right? And I think we're seeing this firsthand with all the projects you mentioned, right? So I think it's fair to say we did expect to see creative use of FSR 2, but certainly not this rapidly after release, right? So based on this and the reception from all the professional game devs that we work with, I think this speaks a lot about the quality of our code and the documentation, which is something we're actually particularly proud of. So yeah, I mean, clearly there's a rich history of modding in the PC industry, right? And we are very happy to support the wider development communities via all our GPU Open initiatives. But of course, right, at the end of the day, an official game integration of FSR 2 will always be preferable to a mod, right? Not only from a pure quality perspective, right, but also in terms of ease of use for all players, right? Because obviously the option is directly in the game as opposed to having to fiddle with DLLs and whatnot. So.
Yeah, and even, the funny thing is I made this question, I sent it off to you guys. And even in the time between when I wrote this question initially, it's already been changed and modded into X amount of games on top of that. From what I've seen, I did test it out. I was genuinely shocked at how good it was. I mean, there's just like minor inconsistencies because obviously it's not an official integration at all. But the thing is, it's like adding this upscaling technology for GPU owners that haven't had it beforehand. It's one of the things that I'm probably most proud of in terms of AMD's FSR 2.0 is like you said earlier, democratization of this technology, because it's been around on consoles since like 2015, 2016, technically before then and some other titles, but it was always been a big thing there, but it felt like it was missing on PC. And it feels like FSR 2.0 is one of the first times where it's like it's going to probably be in the next couple titles just for the next couple of years because that's what people want. And I'm so happy to see it like that. But getting back into the idea of like, okay, there's an interoperability here with DLSS to a certain degree. That's why people can do it at all. NVIDIA detailed like Streamline in April of this year, and they released some code on GitHub. It's GameWorks named and stuff like that. But the idea was essentially that super resolution tech is now here on PC. All the vendors are coming up with their own solution, Intel included. Obviously, AMD is much more open regarding that, though. But the initiative was basically, we want a common API platform plugin interface for developers to use to just make it so that if you have an Intel GPU, you can run XeSS. If you have an NVIDIA GPU, well, then the developer has an easier way to put in DLSS, and same for AMD's FSR 2.0, hopefully. I was just curious whether AMD or you have any ideas about this or a stance on it, whether or not AMD wants to support such initiative in the future.
Right, I'm going to be direct with you here. We don't plan to support Streamline at this time, right? Now, obviously, while we believe that focusing on open source technologies is the best approach for gamers and game developers, inherently, we don't believe that Streamline provides any significant benefits to game devs beyond what is currently available. And essentially, the underlying NVIDIA technologies, like DLSS that plug into it, well, they're still closed, right, and proprietary. So you're talking about having an open source framework that plugs into a closed source technology, right? So if I was to contrast this with FSR 2, obviously it's fully open source, easy to implement, and supported on multiple platforms, including consoles, which I think is actually key to that particular topic. So there is no need for developers to learn and implement a new framework for something that they can already do easily today.
Okay, that sounds very reasonable. I didn't actually have any questions here about consoles at all, but in terms of when developing FSR 2.0, obviously you were taking the millisecond frame time cost of it into consideration with every step you did. Probably it was a huge part of the optimization process. You have different paths essentially for different GPUs. I already know that the Xbox, for example, the Xbox version of AMD FSR 2.0 with Xbox developers can use today if they want. Does that have specific optimizations in it made specifically for the AMD GPU there in the Xbox Series X, for example?
Okay, so that's a very yes or no answer. Yes, absolutely, right? So we specifically optimize for each platform, and that includes optimizing for the Xbox, absolutely.
Is any details into what that may entail to a certain degree? Like, for example, in comparison to the path that's used for like a modern RDNA 2 chip on PC.
Yeah, so you have to remember, so obviously GPU have got different performance characteristics, like the ratio of resources in the system in terms of texture instructions, math instructions may be different and so on. So these are the type of examples that basically would warrant potentially different code path, right? I don't know the exact details, to be honest with you, as to what exactly we did to make Xbox faster, but I do know for a fact that we did do some things to try to get as close to 2 milliseconds as we could on the Xbox Series X, right?
Yeah, it's always, I've talked about this before when talking about like upscaling on Switch, that like, obviously that 2 milliseconds is very fast, by the way. Let's get that out in the audience. Like that's really fast to get the quality you're getting. And, there is a little bit of a tipping scales here. Like, okay, well, it gets eventually too slow to make it worthwhile. But honestly, any upscaling, as long as it's high quality, it can get pretty expensive, I think, and it's still pretty much always worth it. Usually, especially for games, for example, that use ray tracing, where every millisecond counts. So you've got it out now. FSR 2.0 has been out for a while. It is going to proliferate. Developers are already using it. It's already been announced in titles coming up. But beyond the proliferation stage here, how would you personally would you like to see FSR 2.0 advance algorithmically and otherwise, in light of the fact that AMD soon enough, I imagine, is going to be releasing new, probably dramatically more powerful GPUs? Are you just interested in the millisecond runtime getting lower, as in FSR 2.0 becoming faster, or are you interested in using those newer, faster GPUs to make FSR 2.0 different and better in some way?
Yeah, I think good question here. I would say we've got a pretty vast roadmap for upscaling research and development. As you pointed out earlier, we released FSR 1 last year, and we've just released FSR 2 last month or a few weeks ago. So the teams remain focused on improving our current solutions, and in particular, acting on all the feedback we're getting from our developer partners. That's very important, right? Because we want to elevate the experience for everybody. So again, FSR 2 here will get better and better. Now, while GPUs will undoubtedly get faster, I'm afraid I can't comment on any new tech. We may be developing to take advantage of these increased capabilities. What I would, however, say is that if you look at our history, right, we've got a history of ensuring that the developer software we release can scale to a wide range of platforms, right? So I think that is something that is close to our heart. So, but without pre-announcing anything, I would say that this is something that we'd want to maintain.
That makes a lot of sense. Okay, so it'll get better, it'll be faster, but one thing I've always noticed about image reconstruction techniques of all types, ever since they started, is that they're really good at like normal, like rasterized geometry edges and textures. They can like upsample those really well and make them look really crisp and clean and well anti-aliased and things like that. But things that are decoupled from that, that might mean transparency at times, but usually I'm thinking about modern technology like RT reflections. They usually still look pretty low resolution, like more in reference to the internal resolution. That's how they tend to look. Is AMD interested at all in somehow advancing FSR 2.0 in the direction of making ray traced images also look better? Like the aspects of ray traced images also look better?
Right. So I think temporal upscaling techniques such as FSR 2 can actually work with ray tracing effects, right? As long as the rays traced from the camera view are jittered in the same way as rasterized geometry does, right? However, to your point, it is true that some effects, such as reflections, whether they are ray traced or not, can actually be challenging with temporal upscaling algorithms. And that's because, again, the reflected pixels are not correlated to the history because they don't have motion vectors or depth, right? So FSR 2 is already able to support some of those cases via a special mask available to game developers to improve the quality of the final image. That mask is different from the one I mentioned earlier. This one is called the transparency and composition mask. And essentially what it does is to tell FSR 2 to adjust the contribution of any lock that exists for that pixel. And for the full definition of locks, I would invite your audience to maybe check up on the documentation because we're getting into complex territory after that.
Yes, of course. There will be in whatever way this is published, there will be links to AMD's GPU Open, and it is out, so you can look at the GDC 2022
That's right.
Presentation as well. That will also be linked wherever this is posted. Okay, so that makes sense, especially the part about like lining up the jittering between FSR. That's the one thing that is always makes me sad when I see that not happen in a game. I'm like, only if. So we have FSR where it is now. We've just talked about a bit where it might be advancing in the future. 2.x, like machine learning is not a part of FSR 2.0 right now. I think it's been suitably proven at this point that it has a certain level of utility for this kind of thing. And the question is, do you think you would be looking towards using machine learning in any capacity for FSR 2.0 in the future, whether that be in the distant future or closer? So
I think, there is no doubt that machine learning is a great tool, right? I mean, you feed a bunch of inputs and outputs to a machine learning framework so that it can learn the relationships between them. And then once the model is learned, it can be applied to any new input. I mean, in practice, that's great, right? And it can be applied to a range of problems. And obviously, according to public NVIDIA documentation, it is being leveraged by DLSS to reconstruct an image from available inputs. So you can think of ML as a brute force approach to engineering an algorithm, but certainly it is an option. In the case of FSR 2, though, we wanted to provide a quality upscaling solution that could run on a wide range of hardware, right? So we could not really rely on any dedicated machine learning acceleration. It was not an option for us. And to be fair, we're actually pretty happy with where we ended up with the handcrafted algorithms we designed. And now that we know the algorithm inside out, it will allow us to keep improving it in the future. So FSR 2 will definitely be evolving. As to whether a a future ML-based upscaling solution may be released by AMD. You know what's coming. I'm afraid I cannot comment on that.
Yeah, I mean, we always try at least elicit some secrets and some comments there. That's kind of what we do sometimes, but not always. Okay, so well, that really actually, in terms of my technical questions, that lays it all out. That's the things that we've covered. We've covered this in videos so often before. I think a lot of people know it, that the ins and outs of upscaling, we've covered it so often. But one thing we don't often have the chance is to talk with developers like you who are making this kind of stuff, and especially you who is so integral to this project here. What was one aspect or maybe one facet of working on FSR 2.0, or whether that's one aspect of your job during that time that you are really proud of or you were really satisfied with while doing it? Because, you know, we already, the success is there, but what about for you? What does this mean to you?
Yeah, no, that's, I'm actually very grateful you're asking that question, because it gives me a chance to talk about something that is very dear to me, right? So in my role as a senior director of game engineering at AMD, I get to oversee all aspects of AMD's technical relationship with game developers worldwide, right? And FSR 2 is certainly a major piece in that puzzle. However, for me, the thing that I'm the most proud of is really the amazing group of people who made it all possible, right? These are the people you often don't see, right? Working hard to invent and engineer all those solutions behind the scenes. I actually believe we've got some of the brightest in the industry, putting their heart and soul into technologies such as FSR 2. So as a director of this group, I get to have a front row seat to watch the creativity and dedication that it takes to pull off something like FSR 2, right? And believe me, it was hard, right? We had significantly difficult gates in terms of quality and performance and other metrics that we had to pass. And yeah, it really took a concerted effort to get to where we are. So it's genuinely wonderful to get to work with those people day in, day out. And yeah, I'm really, really proud of what we achieved together as a team.
That's wonderful to hear. Teams are so important. Like my coworkers and friends at Digital Foundry are also very important to me. And something that hopefully we communicate in these videos. It's not just about tech. It's sometimes about the experience of loving tech and loving the technology behind everything, because you guys do great work. Just a little bonus round question that I just thought of based upon what you said, like the struggle to make the quality and the struggle to make the performance. Do you remember any kind of breakthrough moment or aha moment at all in the FSR 2.0 project regarding one of the technical aspects of FSR?
Yeah, good question, actually. There is a few of those. Certainly from a quality perspective, yes. Once we saw that we had image quality comparable to DLSS on much of the contents, that was clearly a very, very good news for everybody involved. But then obviously we had a bunch of technologies, right, packed into that algorithm, and it was not as fast as we wanted. So hence all the efforts we put into optimizing for different platforms. So again, once we got breakthroughs in terms of finding new ways to optimize that allowed us to go below certain thresholds in terms of milliseconds, yes, I think there was a lot of joy, in the team, right? So yeah, definitely these kind of moments really made it worthwhile.
Yeah, of course. And the way I kind of round out any of these interviews here, because thank you so much for taking the time to talk to me about this today. If there's any final words you would like to say regarding FSR 2.0, your job, or anything really, is there anything else you'd like to say?
No, I think again I'm pretty grateful for that last question, that because I got to talk about the team of people behind the scenes that do the real work as opposed to me being in front of you and talking about it. But I'm really grateful for this opportunity to talk to you guys, and looking forward to seeing what Digital Foundry is up to next.